Okay, so complex numbers. So we are not in real number system anymore. All right. So anything that we have done so far is real number based. So real number or real numbers are numbers that we use in our day-to-day life, like $5 or 3 gallons or 25 miles or 2.99, whatever, even negative, right? So now imaginary unit. So under complex number, there is something called imaginary unit. The imaginary unit, which is written as a lowercase I, it's just I, lowercase I, is a number whose square is -1. Are we good? So I square is defined to be -1. Similarly, I would be square root of -1. Is that fine? Is that okay? So if you look here, so say we have a square root of 4, right? What is the square root of 4? Well, 2, right? What if I have square root of -4? Well, what is the square root of -4? Remember, back then we said we cannot have a negative inside the square root. So what did we call it? Not a real number, right? So these things are not defined in real number system. That's why we said these wouldn't give you a real number, but these are defined in what we call a complex number. All right. So everybody okay so far? All right. So let's continue with this -4. So -4 inside the square root. All right. So -4. I can write -4 as -1 times 4 if I wanted to. -1 times 4 is -4, right? Is that fine? Now I went from one number to two different numbers in there. So your product rule of radicals allows you to give each of these their own radical sign. If you have multiple numbers under one radical, you can give each of them their own radical sign, right? So I have a square root of -1 and a square root of 4. Well, what is a square root of 4? Well, it's 2. Square root of 4 has always been 2. So I have a 2. Then I also have this, which is square root of -1 with it, right? Well, what is the square root of -1? How is square root of -1 defined? Well, square root of -1 is I. So the answer to square root of -4 is 2i. Are we good? Is that fine? All right. So there are two things, negative and a 4. Between these two things, what is responsible for this I? Just negative, that negative part, right? Are we good? Right. So that negative is responsible for I. 2 comes from 4. Very good. So if I have, for instance, if I have, say, square root of -25. Now these all steps are to explain it to you why, how, and so on. Are we good? All right. If I have a negative inside a square root, my answer is going to have I on it. Right? We good? So what does that negative give me? I, right? Then that leaves me with 25, which is still under the square root. So what is the square root of 25? 5. So what's the answer? 5i. We good? Is that fine? If I have, say, square root of -49, what is the square root of -49? 7i. There you go. 7i. Good. Is everybody fine? All right. So the negative gives you I. 49, which is still inside the square root. Well, square root of 49 is a 7. We all looking fine? Can I move on? Okay. Same thing. We're going to be doing same thing. What if I have a square root of -20? So unlike 25 or 49 or 4 that we had earlier, 20 does not have a square root, right? 20 does not have a square root. One thing I know is that negative is going to give me I in my answer, right? Now this number, which is 20, even though it does not have a square root, it is big enough for us to do a factor tree. Are we good? You remember factor tree, right? So 20 needs to be broken out, 2 and 10, so 2 is a prime number. And then 10 needs to be broken out as what? 2 and 5. And they're both prime numbers, right? So let me go back into this thing. So I have negative and then 2 and then a 2 and then a 5. So that negative is right there, and then 20 is 2 and 2 and a 5. Are we good? Okay, so what comes out from here? What comes out from here? The 2 comes out, right? You have 2 2's, right? You put them in a group of 2. Remember that? So 2 comes out, what stays in? 5 stays in. But wait, how about that negative? What is that negative going to give us? I. So the I that you get out of the negative needs to be written. It always is written outside of the radical sign, square root sign. It will never be inside. So you just put it next to that number that you get. We good? Everybody okay with that? All right, we're gonna do one more and then we'll go to the next thing. Can I move on? We're good? Okay, let's do one more, which is negative 32 inside a square root. This is just to do another example like that. So 32, we know our answer is gonna have I on it, but we also know that 32 does not have a square root, right? So we do factor tree with 32. You've done enough factor tree. So 2 and what? 16. Good. 16 would be 2 and 8. 8 is 2 and 4. 4 is 2 and 2. So you get a bunch of 2's in there. Everybody cool with that? Is that fine? Okay. So I'm not going to write these 2's like we did here. We've done enough of this. You should be able to see what comes out and what stays in. So a 2 comes out here, right? And a 2 comes out here. And then that fifth 2 does not have a pair to come out, so it will stay in, right? So a 2 comes out and a 2 comes out. What comes out altogether?
4.
4, good. And what stays in? 2. This 2 stays in. And then we also have that I to take care of. All right. So where does that I go and sit?
Outside.
Outside, right behind that 4. All right. So that would be the answer for that. Everybody okay with that? Okay. Any question? No. All right. Cool. Okay, so we're going to do some basic multiplication. We have multiplication coming up again, but this is a simple basic multiplication here. Let me erase this thing. Say you have a square root of 3, square root of negative 3 times the square root of negative 5. So what happens when I'm multiplying two things like this where both of them have negative in there or one of them have negative in there? All right, so Good? Okay. So if you look at each of these are, at this point, these are undefined. They really don't have any meaning, right? Because they're not defined in real number system. And we haven't turned those into I form to go into complex number yet, right? So we cannot multiply them right out because they're undefined. We don't know what to do with them. Are we good? So we need to define these. Well, the way to define these is to turn them into their I form, like we've done earlier, right? So they both have negative, so let's talk about this thing. What does that negative give me? I, outside, it's always outside. And that leaves me with the square root of 3. Remember, 3 does not have a square root and it's not big enough to do factor 3. Yeah? So, and then the second one, I still have a negative inside a square root, which means I will get I outside, right? And then similarly, this 5 also does not have a square root and it's not big enough for us to do factor 3, right? 5 doesn't break out, it's a prime number. So now that each of these have been defined, we can go ahead and multiply them. We good? Everybody okay with that? Can I move on? So what is I times I? I square, very good. So I times I is I square. And then what is the square root of 3 times the square root of 5? Square root of 15. Good. So this is where we are so far, almost done. Any question? No? Okay, so in complex number system, the I that we have, we get I in there, but the highest power of I we can have is just one, I. So if you have something like I square, we need to do something with it. All right. If you look at this definition that we wrote earlier, how is I square defined? What is I square? It's -1. So every time we see I square, we need to turn that into -1. So this is going to be -1 times square root of 15, because this is I squared times square root of 15, right? Very good. So, well, what is -1 times square root of 15? It's just negative square root of 15. Are we good? So the answer to that is going to be that right there. Is that fine? Question? Okay. So let's do one more. So square root of -36 times the square root of -1. Okay. So what is that negative going to give me? I. What is the square root of 36? Does 36 have a square root? So what's the square root of 36? It's a 6. So we don't have to do a factor 3. It's just going to be 6i, like that -25 earlier, right? So that, and what is the square root of -1? What is this? Well, this is your I, right? That's the definition of I, right? Square root of -1 is just I. So this just turns into I. Is that fine? Then I have 6i times I, which is 6i squared. I times I squared, right? Is that fine? Can I have I squared as part of my answer? No, the biggest I we write is actually just I. This is a little bigger than that. But so remember, going back to the definition, what does I squared represent? What is I squared? -1. So every time you see I squared, you write -1. So 6 times I squared, so 6 times the -1. What is 6 times the -1? -6. Is that fine? Okay. Alright, so the next thing we are going to do is actually define what complex numbers are, and then work with it. So all we have done is we've been working with this imaginary unit, which is part of the complex numbers. So that is the definition of complex numbers, what a complex number basically mean. Again, complex numbers are not what we deal with in our day-to-day life, so you will get there sometime, like in your physics, math definitely, computer science and so on. So if any number or any number that can be written in the form of a plus bi is called a complex number. So if you see a number that has a form of a plus bi, then you know you're dealing with complex numbers. All right, where this a is called a real part of a complex number, and bi, since b has I with it and I is an imaginary unit, bi is called an imaginary part. So a complex number has a real part and an imaginary part. Are we good? Now you can make as many examples, you can write as many as you want, something like 7 plus 4i. So 7 plus 4i, this is a complex number. Where this 7, that doesn't have I on it, is your real part, right? And then 4i would be your imaginary part. Is that fine? You can make your own example. I can have negative 13 minus 2i, where negative 13 is your real part and minus 2i is gonna be your imaginary part. We good? Okay. So any questions? And we'll move on with complex numbers. So complex numbers, the next thing we'll do with complex numbers is adding and subtracting. So add, subtract, add, subtract. So two or more complex numbers can be added or subtracted, right? I can have a complex number, another complex number, and I can add them or subtract them. Are we good? When you add or subtract two or more complex numbers, the result is a complex number of its own, right? It's pretty straightforward to add, subtract complex number. Let me do, explain that with an example. So say you have negative 5 plus 2i plus 7 minus 3i, something like that. All right. Okay. Well, first of all, how many complex numbers are there? Two? There are two complex numbers. What are we doing between these two complex numbers? We're adding them. So when you add or even subtract complex number, it's like combining like terms. A real part adds with a real part, and an imaginary part adds with the imaginary part. Add as in combine, it combines. Are we good? So just combining like terms. So let's look here. Let's go with the real part. So I have -5 plus what? -5 plus a 7. What is -5 plus a 7?
2.
It's 2. So you get 2. Is that fine? And then now we go to this i's. So I have what? 2i plus a -3i. So 2i plus a negative 2i plus a -3i, right? So basically 2 minus a 3. What is 2 minus a 3? -1. And then of course these have I, so -1i, or 2 minus I. Is that fine? Okay. Let's do one more adding and subtracting. So say we have 7 plus 2i minus -3 plus 6i plus -4 minus 9i, something like that. So you can, add or subtract multiple complex numbers. It's just the same process. So how many complex numbers do we have on this particular problem? You have 3 complex numbers. I'm subtracting these, I'm adding that. Ultimately, we're combining like terms, right? Is that fine? So it's again pretty straightforward. I have 7 minus a -3, 7 minus a -3 plus a -4. So what is 7 minus a -3 plus a -4? 6, right? Everybody okay with that? All right, because negative and negative makes it positive, so you basically get 7 plus a 3, which is 10. 10 take away 4 is 6. Is that okay? And then for the I part, I have 2i minus a 6i plus a -9i. So 2 minus a 6 plus a -9. What is that? So -13, but that -13 is going to have what with it? I. And that's it. 6 minus 13i. Right? -9 and -6 is -15. -15 plus 2 is -13. Is everybody okay with this? Okay. So again, adding, subtracting, pretty straightforward. No twist or turn. Nothing, fancy about it. So, is that okay? Can I continue? All right. So the last thing we are going to do with complex numbers is multiply. So we're going to do 3 examples of multiplication, and then probably that would be it. All right. So here's the first one. So we have 2i outside of the parentheses and 6 minus 3i, right? So what do we do with the stuff that is outside of the parentheses?
Multiply those inside.
Okay, there you go. We multiply or distribute, you may have used that word, to whatever is inside, one at a time, right? So let's do this. What is 2i times 6?
12i.
So 12i. So 2 times 6 is 12, and then 2 comes with I, so 12i, yeah? And then what is 2i times a negative 3i? So 2 and a negative 3 is negative 6. But both 2 and 3 come with I, so it makes it what?
I squared.
I squared. So this is where we are, right? Is that fine? But can this be my answer? Can I leave my answer with I squared? No. Good. So I have 12i minus 6. What is I squared? What was how was I squared defined? Negative 1. Good. So every time you see I squared, we have to turn it into negative 1. So please understand that I had negative 6 times I squared. So now negative 6 times the negative 1, right? So 12i, what is negative 6 times the negative 1? Positive 6. Is that fine? And, is that fine? And the last thing we probably should do here is put that 6 in the front and 12i back here so that we can achieve the form of a plus bi. This is what we call a standard form. So you want to put your real part in the front and then imaginary part next to it. Other than that, that's it. Does it look fine? Alright, so it's just like a basic multiplication. You just have to, be careful that I squared turns into negative 1 ultimately. So say we have 2 minus 4i and then 3 plus 5i. Second example. Is that fine? So I have 2 minus 4i and then 3 plus a 5i. So distributing, multiplying, whatever you call it. We've done again enough multiplication like this. Last time I only had 2i that goes in both of these, right? Now I have 2 and a negative 4 going in there. We good? So let's look here. So what is 2 times a 3? 6. What is 2 times 5i? 10i. Good. All right. Now we're done with this 2. We go with what? Negative 4i. So negative 4i times 3. Negative 12i. Perfect. All right. And then the last one, negative 4i times 5i. So negative 20i squared. Looking good? Okay. So I have 6. These two are like terms that can be combined, right? Is this also like term with these?
No.
No, this is not like term with these because the powers are different, right? So what is 10i minus 12i?
2.
Pretty close. Negative. Negative 2i,
Okay.
right? Minus 20. Well, can my answer have I square on it?
No.
No. So this negative 20 is what that I square is with, right? So negative 20, what happens to that I square?
Negative 1.
Negative 1. So negative 20 times negative 1, right? So you have 6 minus 2i. What is negative 20 times the negative 1? Positive 20, right? Now we get a like term for that one. So 6 plus a 20 is 26 minus 2i. Is that fine? Everybody okay with this? Okay. Do I need to wait or I can move on? Move on? Let's do one more example of multiplication. 5 minus 4i squared. Something like that. from last time, when we have something in that form, the very first thing we do is write that. How many of those?
Two.
Two of them side by side, and they're going to multiply, right? So this just turns into something like that. The fine. Now we have 5 times 5, which is 25. 5 times negative 4i, negative 20i. Alright, cool. And then now we go with negative 4i, so negative 4i times 5. So negative 20 again, and I, because that 4 comes with I, right? And then the last one is negative 4i times a negative 4i. So negative and negative is positive. 4 and 4. 4 times 4 is 16, right? And then they both come with I, making it what? What? I squared. Is that good? Is that good? Then we combine like terms that we have at this point. So 25. Well, negative 20i and a negative 20i is, it's like you've lost $20 and you lost $20 more. You've now lost how many dollars? 40 I, because they both have I on them, right? And then you have plus 16. Well, what about this I squared?
Turns into negative 1.
Turns into negative 1. So it's 16 times negative 1. Good. Are we good? So 25 minus 40i. Well, what is 16 times a negative 1? Negative 16.
Negative 16.
Right? Now that 25 will get a like term here. So now we're talking about 25 take away 16, which is 9. And then you have minus 40i. And that would be the answer for that. Everybody okay with this? Alright.